Hello everyone and welcome back. We're going to continue here with the C puzzles. We're going to do operators 2, assignment operators. So with that, let's jump right back into solving these puzzles. So looking at the program here, we have our main program here. We have our include or standard input-output header along with a defined macro, which I'll explain here in a bit. We have our main body function here. We've declared the integer variables x, y, and z, with x being the only one being initialized at 2 prior to actually jumping to these expressions, following by their macros, and last but not least, the return 0, which will go ahead and exit our program. Some background here before we jump into actually solving these C puzzles. We have this hashtag defined printx, printf, and then whatever the format is here, which is known as a macro. The hashtag define is a pre-processing directive in terms of C language. What this hashtag define is it'll be evaluated by what is known as a preprocessor, which is just software that edits C program code before compilation, where the behavior is ruled by these pre-processing directives. In this program, we actually have two directives here. We have the include and define here. So in this case, define, all we'll do is we'll go ahead and define this macro here, which is printx, to just be a replacement for this printf function. So anytime we see this printx macro, it'll be replaced or expanded by the printf function by the preprocessor. Once again, before jumping into these programs, the precedence and associativity still play a big role. So therefore, when solving these puzzles, we got to once again look back at our operator precedence and associativity table to make sure we're actually following the rules of the level of precedence. So the compound assignment in this case will be our main focus of this puzzle. So what is the compound assignment operator? Well, they're operators that use the old value of a variable to compute the new value, then to be assigned to that variable. What does this mean? Well, let's go ahead and do an example. So suppose we have the integer variable x assigned to be equal to the value of 5, and we have the following expression: x is equal to x plus 2. Well, what's going to happen here is on the right hand side we have this addition expression here, and on the left hand side just the value of x. And because the addition has a higher precedence over the assignment operator, which we've seen before, we're going to evaluate the right hand side first, and whatever the result happens to be of this addition operation will then be assigned to the value of x. So we can go ahead and close x plus 2 in parentheses, and because we said that x is going to be assigned to 5, we'll replace x to be 5, and we have 5 plus 2, which will be 7, and then lastly we'll go ahead and assign 7 to be x. So after this expression, x, which was initially 5, will now be 7 here. Now, where the compound assignment operator comes into play is that this whole expression, x is equal to x plus 2, can actually be shorthanded to x plus equals 2, where this plus equals is the actual compound assignment operator. This is a shorthand way of saying this whole expression here. Now, of course, you can still use this expression if you wanted to, but a lot of C programmers use this, shortcut, shorthand way of writing it. Now, if we go to the generic form of this plus equals, if we have some integer variable x plus or minus or plus equals y, this is going to be, we can expand this to be x equal to x plus y if and only if y is a constant. So for example, here we saw that x plus y equals 2 being a constant. If y here is also a value like 10, then this can be actually valid. But if y happens to be something that's not a constant, like an expression, well, this may not be true, and we'll see here shortly how that can actually affect the actual expression in the overall operation. Now, the addition compound assignment operator is just one of many compound assignment operators. We still have the subtractive, the multiplicative, the division, and the modulo operator, all compound assignment operators which do the exact same thing as the addition, which you can expand this out here, but with their associative operators. So let's jump into operators 2.1. So before we jump into the actual expression, we have some setup here. We said that we initialized the variable x to be 2, and we've declared integer variables y and z, which right now have no values or no initialized value to them. So we have x is equal to the multiplicative compound operator assignment, 3 plus 2 on the right hand side, followed by a call to the printx macro. So In the expression we have, in the statement, we have two operators. We have the multiplicative compound assignment and the addition. So which operator do we evaluate first? The one with the highest precedence, which was the additive operator. So we do the addition operation. So we'll go ahead and close 3 plus 2 in parentheses and evaluate 3 plus 2 to be 5. And because 5 itself is a constant, we can go ahead and expand this compound assignment operator to be x is equal to x times 5. Recall that that x was initialized to the value of 2, so we can go ahead and replace the value of x with 2, and once again multiply 2 times 5, which is the expression on the right hand side of the equal sign. 2 times 5 will give us 10, and lastly we'll assign the value of 10 to the integer variable x, followed by a call to the print x macro, which would just go ahead and print the value of 10. Operators 2.2. So here our setup is that we have x to be 10 and we have y and z, but note we don't actually initialize x to be 10. We're just saying that from our previous statement here, after we evaluate this expression here, the resulting value of x was 10. So therefore, jumping into this next expression, x starts out to be 10 and y and z are still uninitialized because we haven't actually assigned them to be any value. We have x is equal to the compound operator assignment, y equals z equals 4, and once again a call to the print x macro. So in the above statement we have two operators. Once again I said the multiplicative compound assignment and just the regular old assignment. So which operator do you evaluate first? The one with the highest precedence, but in this case both the compound assignment and the assignment have the same level of precedence. There should be a typo there, excuse me. So since both have the same level of precedence, we'll go ahead and use the associativity, which is from right to left. If you go ahead and look at the operator precedence table, we see that the assignment and the compound assignment operators are on the same level, which is the second to last one here. So if we jump to the associativity, we see that we're going from right to left. So starting from the right hand side and going from the right, going all the way to the left, we see we have 4 equals z. So we go ahead and try to enclose that in parentheses, which is really just an assignment operator, or in this whole case, this whole chain of assignment operators. We'll begin with the very first link of the chain, which is that we assign the variable 4 to be to the variable z. The result of this assignment will then be z, which is the value of 4. We'll then go ahead and then assign y to be equal to z, which once again is 4. And lastly, now we have x, the compound multiplicative assignment operator y, which we can expand to be x is equal to x times y. And because the multiplicative has higher precedence than the assignment, you can go ahead and evaluate this x times y on the right hand side. Note that x was 10 to begin with from our previous expression, and y currently has the value of z from this assignment, and z has the value of 4 from this assignment. So therefore we have 10 times 4, which gives 40. We'll assign to x, and call of a print x macro will print out the value of 40. So as I was mentioning here, that the x is plus equals y is not always the same as x equals x plus y. And this holds true if and only if y is a constant. But this is also not the case for having other compound assignment operators. Here's just an example here. This can also be the case with the multiplicative or the division, and we'll look at a special case right here. So if you have the expression I star equals j plus k, this is not the same as I is equal to I star j plus k, as you might think, right? Because if you have I is this, you would do I is equal to I plus whatever is on the right hand side, just like we did. Here we have x star equals y, so x equals x times y. You would jump to the, we have I star equals here, so I is equal to I times whatever the right hand side is here. But this is not going to hold true. And we'll look at an example here. Suppose we have I and j and k to be initialized to values 2, 2, and 3 respectively. So in the first case here, if you look at this case here without trying to do this expansion, we have I star equals j plus k, replacing j and k by 2 and 3 with their respective values. 2 plus 3 will give us 5. And now if we go ahead and expand this multiplicative compound assignment, we get I is equal to I times 5, but I once again is 2. So 2 times 5 would give us 10, and we'll assign 10 to I. Looking at the other case here, where we had to have thought to expand, or to go ahead and expand it out initially here, replacing the values equivalently, we have I star j plus k. Now note that the multiplicative on the right hand side of this expression has precedence over the additive, so the result of this multiplicative will then be added to k. Replacing I and j with their values of 2 and 2. We get 2 times 2 will give us 4. We'll add 4 to 3, which gives 7, and assign 7 to I, which is not the same as 10. So therefore we can see that expanding out here gives us the actual incorrect answer, as opposed to following the rules of precedence and see that this expression here actually results in the value of 10. So you must be careful with how you actually expand these compound assignment operators, especially if the right hand side is not a constant and rather an expression. Operator precedence and associativity once again will take place and take priority. So with that, thank you all for watching, and part 2 coming soon.